Wi-Fi allows connectivity and communication among devices in a wireless fashion. The RANGERNeo series will offer you the possibility of analyzing Wi-Fi signals in the 2.4 GHz band. The 2.4 GHz band is used by several technologies simultaneously, such as Bluetooth, wireless USB, Zigbee used in domotics, cordless phones, security cameras, microwave ovens, etc. And therefore it is necessary to have a tool that can analyze how busy the spectrum is with all these signals. To use this tool, we will go to the settings menu by pressing the wheel button and choose Signal Source Wi-Fi. The meter will activate its Wi-Fi adapter and scan all in-range Wi-Fi networks. Now we can access to two different screen modes. The Wi-Fi spectrum screen can be accessed by pressing the Spectrum Analyzer Mode button. Here we can see the 14 Wi-Fi channels within the 2.4 GHz band. The Spectrum Analyzer trace is plotted thanks to the signal received through the meter's RF input, while the network's access point information is displayed on top. It is important to understand that this spectrum screen will display not only Wi-Fi signals but any signal using this band, as those coming from security video cameras or others, which can be interfering our Wi-Fi network as well. By pressing F1, we can select whether we want to move in the spectrum frequency axis, by channel or by access point. When we choose access point, we will jump from one access point to the next or previous every time we press right or left with the joystick respectively. The access point selected is highlighted for ease identification. When moving by channel, the marker will jump from one channel to the next or previous by pressing the joystick right or left. Both reference level and span can be modified in this screen. On the top of the screen, we can see the RF channel where the access point is assigned, the bandwidth for that access point, the maximum power and average power received within that bandwidth occupied by the access point selected, the number of access points using the same RF channel, and finally, two measurements for the specific access point we have selected: the received signal strength indicator RSSI and the signal to noise ratio SNR. In our case, we can see that our local Wi-Fi network, called Visitas, is received with good signal strength, and when reducing the span, it is as well clear how many networks are using the same or part of the same spectral band for communication. Close inspection of the spectrum trace tells us if other interfering signals, not Wi-Fi but using the same frequency band, are present. All this information can help us to decide what is the best RF channel to use. Persistence function in the spectrum analyzer will help us determine, among other things, the channel usage level, or identification of non-Wi-Fi signals, such as those generated by microwave ovens or some wireless video cameras. The more signal presence in the channel, the brighter they will appear on the screen. If we press the Measurement Mode button, we are shown a chart listing all the Wi-Fi networks in range, with their SSID, Service Set ID, BSS, Basic Service Set ID, RF channel used by each Wi-Fi network, their RSSI, and their type of Wi-Fi protection access and Wi-Fi adapter used. Here we can select any network on the list and press F4 and access to very detailed information for that network.